This is TWIS. This Week in Science, episode number 950, recorded on Wednesday, November 8th, 2023. What's the cosmic log on science? Hey everyone, I'm Dr. Kiki, and tonight on the show, we are going to fill your heads with yeast, robots, and cats. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Disclaimer, disclaimer, disclaimer! It's through experiences when young that we find ourselves when older. Our experiences shape us and who we want to be, eventually leading to who we become. Today is National STEM or STEAM Day, a day to encourage children toward a love of science, technology, engineering, and math that might one day lead them to a career in one of those spaces. But really, is one day enough? Shouldn't we encourage our children to embrace curiosity and making every day? Shouldn't we? And isn't every day an opportunity for people of any age to experience the world anew? To embrace a new interest, whether for hobby or for economy? We make every day a celebration of STEM or STEAM or whatever acronym you prefer here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science. It doesn't sound right coming out of me. Justin's voice is much better at doing this, but he is off doing science right now. Thank you all for joining us for another episode of This Week in Science. And we have a great show ahead. We really do. On the show, we have all sorts of science news. I have news stories about editing some yeast, bodiless starfish. I mean, how do you have a starfish that doesn't have a body? Lots of robots and lots of cats. And we are joined by the wonderful Alan Boyle, science writer and host of the Fiction Science podcast. Thank you for joining. Welcome to the show, Alan.
Well, as they say, glad to be here.
I hope.
How many times have you heard that?
One or two. Yeah, a couple.
Mm-hmm,
yeah.
mm-hmm.
You come. Oh, glad to be. I hope that you really are glad to be here. And I hope that we can enjoy a little bit of science conversation. Are you ready?
Sure. Yeah. Let's do it.
You've written about science, you podcast, you have a little experience. You ready?
Yeah. I think your question was, what is the cosmic log? And cosmic log has been around for 22 years. So I've been around the block. So
about as long as This Week in Science.
Yeah.
Let's do it. All right. Okay, everyone, as we jump into the show tonight, I want to remind you that subscribing to This Week in Science as a podcast on your favorite podcast platform is a wonderful thing to do. If you're not yet subscribed, go to wherever you find your podcast. If it's Spotify or Apple or whatever, subscribe to This Week in Science. That's great. You can also find us on YouTube, Facebook, Twitch. We stream weekly, 8 p.m. Pacific time-ish on Wednesday nights. Every week. That's what we're working on. Maybe for a little while, it might just be me and my special guests, but that's going to be a lot of fun for you because it'll be a surprise every single week. It'll be like one of those, what are those Kinder eggs that people get in Europe? Anyway, that's a surprise inside. If all this is too much information, you can find us on social media. Maybe we're out there, but twis.org is the website. That's where you can find show notes and all sorts of information about the site. Click those likes and everything, because now it's time for science. All right. What is the science this week? I'm going to start us out with a very, I think, exciting long-term scientific project. Researchers involved in a project that is called the Synthetic Yeast Project have been, they have a website that they have been working on since I believe they first reported about what they're doing about 15 years ago or so. And they are working on making a synthetic yeast. We've talked on the show about efforts to make synthetic bacteria, and synthetic bacteria are one thing because they're prokaryotes, right? They don't necessarily have a nucleus. Yeast, however, they have a nucleus that's separated from the rest of the cell. There's a membrane that separates the chromosomes from everything else in the cell. And these researchers have been working on basically doing that whole thing where you have a boat and you remove a plank and put in a new plank and until you've rebuilt the entire boat, or you could do it with a car. I mean, is it the same car? In this case, it is definitely not the same yeast because the researchers they've now reported, and it was a suite of papers that were published in Cell Genomics this last week about their work on the Saccharomyces yeast genome 2.0. They have gotten 14 chromosomes copied, which means they have synthetically created 14 out of 16 chromosomes in this yeast's genome. Okay, so they're like, if you could imagine little chromosomes, little copies of DNA, doop, 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 16 of them, 14 of them they've done. Now, not only have they synthetically copied and made synthetic copies of all those bits of DNA, of chromosomes, they have taken some of those chromosomes and put them into the yeast and used yeast mating techniques to get these new chromosomes into the yeast so that the yeast cells survive. They have now gotten to the point where they're over 50% synthetic chromosomal material. One of the chromosomes is a completely synthetic bit of DNA that's actually transfer RNA. It codes for transfer RNA, which is really important in getting stuff out of the nucleus into the rest of the cell. And in what they've done, they've gotten to a point where they think they can keep going. They definitely are going to be able to create the 16 synthetic chromosomes. It's just a matter of figuring out how much DNA can be removed and synthetically replaced in a yeast cell, a eukaryotic cell with a nucleus, before it breaks. How much can be changed? How much has to stay the same to allow the yeast to survive? And that's where we are right now. Alan, do you think that we're going to make it to a completely synthetic yeast chromosome, or not chromosome, but yeast DNA?
Well, I think it's possible. It's a little scary, but they've been working on this for quite a while. You know, Craig Venter has talked about, what the minimal genome is. How much can you remove and still have something that can replicate itself and still have that process we call life? And why are they doing this? It's not just to be a Franken yeast.
I know. Is this Are we creating Frankenstein's monster in yeast?
I think that's the fear. I think that's the fear. Because but the application could be, for example, if you want to make biofuel, you could genetically engineer yeast. It's well suited for making biofuel, or you plug in the thing that you want, whether it's pharmaceuticals or maybe there's some sort of food application you could do for this. But I think there's a little bit of scariness to this too, because you are fiddling with the code of life, and so I'm not totally sold on the idea.
Interesting. Yeah. I mean, I think it's fascinating. You're coming at this from your history as a science writer. And so there is always that kind of, what is the eventual result from this? What are we really trying to do? And I think your point bringing up the fact that they're trying to, they say, we can make medicines, we can synthetically get these yeast to be machines, right? To do our bidding. But they're biological, and so can we keep them? I don't know. There's the the
it's like
control
a
aspect.
Jurassic Park sequel almost that you have to build in the safeguards, and then you have Malcolm, the character coming in saying, "Well, life will find a way."
I wish Justin were here to be able to try and do that quote by that actor who looks like him. Yeah. I mean, I find it exciting. I think they are also part of what they're doing. And we'll talk more about this later when we talk about cats. But part of what they're doing is removing repetitive genetic sequences. So there are lots of copies of genes in DNA, right? Chromosomes in mammals, copies. How much can you get rid of and still have things work? How much do you really need? Like they're trying to do with the minimal bacterial cell kind of efforts. What do they really need, and what are they going to? What is needed for life?
But again, you have unintended consequences. If I could kind of play the Jeff Goldblum character for a second here, that a lot of this DNA, they used to call it junk DNA or now non-coding DNA, but it turns out that a lot of that information has an effect on processes that may not be your traditional DNA coding for protein process, but so you got to be careful when you're doing this. That's the bottom line.
I do hope that these scientists are very careful and continue to be careful and take the responsibility of what they're doing very seriously. I know that that's a big conversation these days about the ethics of these kinds of sciences.
And so that's why a show like this is useful. You get people keyed into all this, and then they can have a rational conversation when it comes to deciding what the policy is going to be.
Right. I mean, and I mean, that's what I hope is that, this is going on, as opposed to sensationalism. We can talk about it rationally. And if people have questions, please ask. We will try our best to answer these questions. But we will, of course, put these links to this story and to the entire synthetic yeast project. They've got a GitHub. They've got all sorts of information. This information that they're working on is public. Actually, it is not private behind paywalls. They've been publishing this stuff, which is fairly fascinating. Okay. Long-term research I always love, because it's like the Human Genome Project. What other things are taking decades to complete, right? But moving on from there, other things that we've been studying are viruses. Yay! Everybody knows viruses that give them colds and does bad things, right? But not always, because sometimes viruses are just microbial material that infects other microbes, the bacteria. And in a recent study in Nature, scientists have visualized two viruses linking up together as they entered a bacterial host, which has never been seen before. So to put this in perspective, historically, when we talk about the viruses that infect bacteria, they're called phages. Phages are often accompanied by what they call satellite nucleids, which is like little bits of protein that just kind of stick around. And they're like little moons for the viruses. They don't do their own thing. They go with the virus. They're kind of like the virus gang. And when the virus infects the bacteria, those little proteins help the virus do what it does, potentially. That's what we think. But there's always this kind of, it's like messy asteroids or moons, and they're called satellites. But now when the student project, and I love this because it's like this kind of this thing that was never expected. It was a student project where the students were imaging viruses, these phages entering bacteria, and the researchers thought that they were going to see the same thing they always see, but there was something messy. And they tested again, and like, wait, that's messy. What's going on? And so they did some scanning to see what was happening in the data, to see exactly what was going on. And they actually were able to image and detect what is now considered, for the first time, a satellite virus. It doesn't have any of its own replicative machinery or any of the genes that would allow it to make use of the host cell's tools for replicating. And so it's like a passenger on this larger virus. But in going in, it also, they determined, works with the virus to do the business that the virus needs done. So they were looking at these particular images, which I think were it's a beautiful image of the tail of the satellite virus and the capsid. It's got like a little hexagonal covering for its genetic material and a little tail. It's like wrapped around the neck of the bigger virus, which is pretty beautiful. And in what they saw, what they were looking at is what they call this phage satellite system. They were originally looking at the mulch and mind flayer viruses, which are phages. And in looking at the mulch and mind flayer viruses, they were later able to specifically identify these little helper satellites. And so the mulch mansion has the mulch room that goes with it, and the mind flayer has the mini flayer virus that is a satellite that attaches to it. So this flayer system, which I'm guessing it's from Dungeons and Dragons or from
Stranger Things. Yeah, Stranger Things. Watching too much Stranger Things can really mess you up. Yeah.
I mean, years ago it was video games, but yeah. Anyway, that's where it is. I love this story because it's a determining of something new out of something that was expected. So expecting one result, finding something new, and now there's a new category of these little satellite objects that are even smaller than the phages that infect the microbes that inhabit us and all the life around us. There's little worlds. It's turtles all the way down, Alan.
Well, again, I haven't seen the story. I'll have to catch up with it. But the first thing that comes to mind is, well, what does this mean for virology and also for fighting viruses? Like, could this be a target for future vaccines where you don't go after the mama virus, you go after the messy little baby virus or baby subvirus? Or can you use it for something? You know, viruses have been used for a long time to introduce genetic material into the genome. And so maybe perhaps there's a less invasive way that you could get transfer of genetic material for genetic engineering purposes, for gene therapy, if you were to use something like this attached to a benign virus, something that is totally safe. So you know, and so there are potential applications, I suppose, for this. I'll have to read up on this, get myself up to speed.
It's brand new. So yeah, we all have to get up to speed. You know, and like I said, it was a student project that became something much, much more. And science is like that. Researchers never really know what they're going to uncover when they turn over that, I don't know, bacterial phage rock. But yeah, in this case, I find it interesting because for virology, I'd love to speak to somebody like Vincent Recchignello or someone else who works in this area to see really how this could impact the ecology of using like phage treatments and other things that we're looking at for fighting infections. And yeah, fun times. Okay, when you think of life, and like we think of like, hey, I've got a head, and like not just life, but mammalian life or fish or the forms of life that we're familiar with as not plants, and more on the vertebrate side of things. Head, body, maybe some limbs, right? You've got the sensory organs in one place. You've got locomotion limbs for getting around. Starfish, echinoderms.
Speaking of turning over a rock, there you go.
Oh, there you go. Where is a starfish's head? Apparently, it's everywhere. Apparently, starfish have gone through an evolutionary process that has pretty much completely gotten rid of their body. So the hypotheses historically were that maybe the head was on the top of the starfish, and then where the little feet come out and move the starfish around on that. Maybe that's more the body part. Maybe it was separated that way bilaterally. Or maybe the head is more out at the end of the arms, like octopus brain style stuff, and then the body's more in the middle where the stomach is, which you could see as possible. But published this last week in Nature, researchers have determined that the starfish, the echinoderm, has, through genetics, it's gotten rid of its body. Doesn't need it. It's all head. And that is it. It's all about the head. The researchers at the University of Berkeley, at Stanford University, also at Chan Zuckerberg Biolab, they used genetic methods and a method developed by Pacific Bio, PacBio, which is nanopore technology, to be able to do long sequencing reads of the genetics of these starfish that they looked at. And we're able to see that these sea stars and starfish, all the genes led to there's no body plan. Gene expression was exactly corresponding to the forebrain in humans, was located along the midline of the sea star's arms, and the human midbrain toward the outer edges of the arms. And then there were other subregions of the head that are expressed in the more trunk area. And now they want to look at a whole bunch of other related organisms to get an idea of how many other sea cucumbers, sea squirts, other echinoderm-related organisms have no bodies at all, just like the starfish. Do you think you could get along without a body?
Well, I was just thinking about, the whole idea of alien life, how alien life could very easily be different from how we conceive life being organized on Earth. And so maybe we've got aliens in the ocean, in the littoral areas, just offshore, because you mentioned octopus intelligence and the fact that they do have neural equipment in their arms that basically are a little bit autonomous. That
right.
Those neural networks in the arms can kind of do their own thing independent of any sort of central nervous system, whatever that means for an octopus. And so it sounds as if this hints to a similar evolutionary path. It'd be interesting to see what they find with other types of creatures, sea cucumbers. I know that a couple of years ago, I was writing about the big disaster that was hitting sea stars, that there was an environmental
disease,
wasting disease. Yeah. And you kind of wonder what it would be like for a sea star to be losing those arms, and how does a sea star think? Would
my
some
gosh,
of its consciousness drop off?
You just totally brought that to a completely different framing. Exactly. It's not just losing a limb, it's losing part of your brain, losing part of your head.
Well,
all the sense.
Glad to blow your mind.
Thank you. Well, I'm glad I'm not a sea star, because I would apparently have no head anymore. Blown completely. Let's see. Robots. Do you like robots?
They're okay. Yeah.
Historically, we've erred on the side of world robot domination on the show, rooting for the robots, but while at the same time kind of hoping that humanity can, we don't want to get on the robots' bad side.
Yeah. Well, I, for one, welcome our new robot overlords. So there you go.
Yeah. Well, thankfully, apparently, according to a review, a study in Frontiers in Robotics and AI published this week entitled, "Do Robots Outperform Humans in Human-Centered Domains?" Yes and no. So they tried to do an apples to apples comparison of humans versus robots. So, Alan, do you have any thoughts on the problems that might come up there?
Well, it's like apples and oranges, no matter how you cut it. That, when you're talking about artificial general intelligence versus some robot or actually an AI agent that can play Go or chess, I think that some of the studies have indicated that it's a long way from being able to master something like a poker game even, or Warcraft, World of Warcraft, or StarCraft, to go into the realm of general intelligence where you have to really come up with a solution to a novel problem, something you haven't faced before. So there's a big debate over, well, can AI agents actually do that? For me, the robot is just the mechanism. It's actually the software-based agent behind that really
is the more important part.
Yeah.
And I think that's what this study really brings to the front, is that when they compared the sensory systems, eyes versus cameras, legs versus robotic limbs, the speed or the strength or the sensory aspects of that particular system that a robot is designed to be good at using very often outperformed humans. But when it came to needing some kind of ability to adapt, to change your plan, to be able to move differently, humans are still on top when it comes to that, because at this point, even with AI and even with the ability of AI to do all these, newfangled things, where it's still not at the point of the human brain and nervous system and how the embodied human or even other embodied animals are designed to exist in their environments.
Okay.
So bottom line, thankfully, do robots outperform humans? Kind of, but not most of the time, not really. I mean, or when it comes down to it, humans are still better. You can't take the robots off the tether very long, and they need lots of power, and then their batteries die. We still haven't fixed that problem. Anyway.
If the robots ever to come to take over the world, make sure you can pull the plug or take the batteries out.
Yeah, just remember all of those fancy videos of the robots doing dance routines or calisthenics or whatever it is. They've been programmed, and those videos are very specifically made also to highlight how great the robots are, not the failures of the robots. It's all about PR, people.
Yep.
And in terms of other robots that, don't need to outperform humans, but just it's the last story for this part of the show, Ohio State University is involved in talking about a robot called the Rhombot that was just published about in the Proceedings of the National Academy of Sciences. And the Rhombot is a soft-bodied robot. And the idea behind the Rhombot is that by using soft robotics, paleontologists, people who study old things from dead ground, fossils, soft fossils that might not actually have made fossils, right? Those soft organisms that might, like the sea cucumbers, that might not have turned into a fossil that could have been looked at by anyone, that we can use soft robots to try and mimic the bodies or what those old animals might have been like, and give us an idea from what we know of the fossil record of how life might have moved, how it might have existed, and how it might have actually worked within an ecosystem. But using robotics, which I honestly was not looking for the day that I would be saying robots are helping paleontologists. Wasn't expecting that one.
It's intriguing because we're talking about simulating how an ancient organism may have moved, and on one level, you can say, well, you can just build a software-based, totally, digital simulation of what that organism might have been like, and you can tweak it and see, well, if this muscle was here, maybe it would have moved in a slightly different way. And so why do you need to build a soft robot to do that? And so it strikes me, one of the stories that I had been covering for a long time had to do with this guy, Nathan Myhrvold, who was one of the early executives at Microsoft. And he's a big...
one of the fathers of computing.
Yeah, but he's also kind of he's a paleontologist. He's a man about many things. He also writes cookbooks. But one of the things that he looked into is how fast could a dinosaur's tail move? And his claim was that the tail could go supersonic. That the
kind of
dinosaur,
like the shrimp. The shrimp claws, where they're creating plasma bubbles.
Maybe, but more like Indiana Jones cracking the whip, and use that as a weapon. Yeah. And so there was a big debate over whether that could possibly be, how fast could it move? Could it go supersonic? And so what he did with his fellow researchers was actually build a dinosaur tail that they could whip around and do the analysis of. And so he claimed that this supported the idea that a dinosaur's tail could go supersonic. And other researchers have said, no, the material that the tail was made out of would not support moving it at supersonic speeds. And so there, again, there's a whole debate over what a creature that lived 70 million years ago was capable of doing. And nobody can really probably definitively answer that question, but it makes for a fun debate. And it's kind of fun to see that dinosaur tail whipping around.
Yeah. And so these robots, whether soft or hard, are enabling researchers looking into the past to be able to maybe hopefully figure out a little bit more than they could otherwise.
And you're right. Robots are fun. So
robots are fun. Now I want to make a whip cracking robot with a tail.
Yeah.
Like, maybe that'll be
Maybe
how I get into battle bots.
Maybe
right?
Nathan will let you whip the tail. I think that would be a fun thing to have in an amusement park.
Oh gosh, that would be so much fun. Oh my goodness. I hope that you all are having so much fun right now. This is This Week in Science, and we've been talking a lot for the last half hour or so, and I just really want to take a moment to really introduce Alan and let you all know who I have been talking to for the last half of the show. Alan Boyle is an award-winning science writer and someone I've had the honor to know for many years. I think the first time I met Alan was at a National Association of Science Writers meeting where you were my mentor and were amazing at introducing me to people and helping me to learn just the very, very beginnings of the world of science communication that I've been delving into. And over the years, you've elucidated topics ranging from the Mir space station to making a case for Pluto. By the way, he wrote a book called The Case for Pluto. Genetic genealogy, the future of energy, the new space race. I mean, you've written a lot about space. Yeah. That's for sure. And beyond. And you're writing for GeekWire and Universe Today as well. And you have your own blog, The Cosmic Log, that you said has been going for about 22 years. You're hosting the Fiction Science Podcast, which is amazing. And honestly, you've been doing so much. I want to find out what you've been doing lately, what you've been excited most about in science and space. And again, thank you so much for joining me.
Sure. Yeah. Well, you mentioned the Fiction Science Podcast, and that was actually a pandemic project. It turned into that.
Okay.
There was a colleague of mine at GeekWire who was really into science fiction. And so I said, well, in a couple of years, I'm going to maybe dial things back a little bit and I might have some more time. And wouldn't it be fun to do a podcast about the intersection of science and fiction? What sort of fiction does science inspire, and what sort of science is really contained in these works of fiction, whether it's the latest, Ice and Fire from George R.R. Martin. How would dragons work if they really did exist? Or whether it's The Expanse, and could you actually do some of the fight scenes that you see on The Expanse? And I've done my share of those stories through the years. And so I said, well, why don't we do this? Let's make a fiction science podcast. And so when the time came and I said, okay, it's time to do this, he said, I'm too busy. I can't do it.
No.
But he did put me in touch with Clarion West, which is a writer's workshop in Seattle. And they have a lot of great writers come through there. And so the folks at Clarion West put me in touch with a science fiction writer named Dominica Fetaplace. And so she is my co-host for the Fiction Science Podcast. And we've been doing this since 2020. And we're not in the 900s yet. We're not in the 900s yet, like some people I know, but we're getting close to the 50 podcast mark. So that's
great.
It's been fun.
Congratulations.
Thank you. Yeah. Padawan. Yeah. The latest one that we did was on space, which of course is a favorite topic of mine. I've done a lot of stories about the commercial space race and the implications and the bigger issues surrounding how are humans going to get into space and build a long-term future there? Is space settlement actually realistic? This is something obviously that Elon Musk has talked about quite a bit, making humanity into a multi-planet species and building a city on Mars.
And they talk about this generation being the Mars generation.
Right.
Yeah.
Mm-hmm, yeah.
Oh, dear.
And Jeff Bezos talking about having millions of people living and working in space. I've heard this for many years and have reported on what their visions are. And so a couple of folks, Zach Weinersmith and his wife Kelly Weinersmith. He's a cartoonist. If you know Saturday morning breakfast cereal, he does that cartoon. And Kelly is a biologist, basically behavioral. She's a parasitologist, and also a behavioral ecologist. And so, but they have done, a lot of looking into what's the reality behind the vision here. They did a book called Soonish, which looked at 10 emerging technologies. And so they followed up with this book called A City on Mars. And what they expected to do was to have kind of a guidebook, like, oh yeah, we're going to have space settlements and this is what they're going to be like. But when they started looking into it, they discovered, oh, there are some real problems here. And one of the biggest problems is, how are people going to reproduce in space? Nobody knows what zero gravity or reduced gravity is going to mean for reproduction and development of children.
Yeah,
and
we can make salad. Maybe
salad, yeah, but
salad.
Kids?
I don't know.
That was one of the big issues that they pointed out, is that a whole lot more research needed to be done into reproduction and development, and also space law. I've been covering space law as it relates to property rights in space for
years.
More than a decade. They were talking about this. There was actually a law in 2015 where the federal government said, okay, we can't claim territory. We can't claim sovereignty over territory on another celestial body. But if you're a U.S. person, if you're an American commercial venture, you can extract whatever you can extract from an asteroid or a moon. And that could be problematic when, you've got China and Russia fighting over
all those resources,
over the good stuff.
Everybody launched to get to the same asteroid, and we're all trying to, are we going to work together, or is it going to be corporation versus corporation? And what are the legalities to all of it?
Yeah. And if you've watched the For All Mankind TV show, you know that it's pretty problematic.
I haven't watched it because I'm so scared of it being too depressing.
Oh, no, it's cool. You should maybe I'll have to find out if I can gift you some access to Apple TV, because it's an alternate universe show, which I always like, what if show. So it's going to be 2003 and there are people on Mars. So awesome. But it's fun. But anyway, that was what we discussed with Zach, is what's the reality and what needs to be done. And so that was a fun podcast that's addressed a subject that I've covered for many, many years. And another one is artificial intelligence. We talked a little bit about artificial intelligence, and, generative AI is a big issue now. And one of the folks in the science fiction community who has done the best job of telling that story and delving into the implications of generative AI is Ted Chiang, who lives here in the Seattle area. And he's the guy.
He was in, the 3-body problem. Is that the book?
No, he actually is a short story writer.
Oh,
and he's best known for writing the short story on which the movie Arrival is based. And this whole idea of how do you communicate with, say, starfish?
Right? How do you communicate with a starfish?
Yeah, if you remember that movie, the aliens look a lot like starfish, and maybe they had their brains in their arms, for all we know.
Or maybe they had, maybe their brain was all over. Yeah, I remember interviewing the science advisor for who was the linguist for Arrival. When that movie came out. And I just love the way that they were able to take the reality of how a linguist works and, what they would put on a whiteboard and how they'd start to try and piece together the basics of a language. And, this wonderful story came out of, this very insightful short story by Ted. So, Yeah.
So
Yeah.
we
So the
did
AI
have.
stuff that he's been working on that you talked
We
with him
had
about.
him. I moderated a panel with Ted and actually the screenwriter for Arrival, talking
Awesome.
about what's going on with the screen actors and the screenwriters strike over generative AI. And just in the last few hours, there was a report that the Actors Guild was reaching a tentative settlement with the
yes.
studios.
Maybe at 12:01 a.m. the strike will be over and we can get new seasons of shows that we like.
That's right. Yeah. New seasons of For All Mankind, season 5. So there you go. Yeah. But generative AI was a huge issue in those strikes. And the whole idea of, well, there's a digital twin. Like actors have their bodies scanned so that they can generate. Yeah, that's right. And who has the rights and what happens when the actor dies? And the studios were saying, well, we'll compensate you while you're living for the use of your digital likeness. But once you're dead, it belongs to us. And so that did not sit well with the actors. So, but those are the sorts of issues that I love getting into. Just
and like you said, issues. With your conversation, also the question relating to the techno-optimists manifesto,
yes,
the Mark Andreessen
like Elon
manifesto
Musk and Mark Andreessen, all these guys,
yeah. How does their viewpoint play into the development of the technology that we're using, and how is that going to influence the artificial intelligence that is going to be applied to our everyday?
Right. Mm-hmm.
Yeah.
So that's a huge. We're going to be watching that, and I'm sure that there will be more about that in Cosmic Log as the weeks and months and years go on. But I did want to mention that Ted is going to be speaking about generative AI again later this week in Seattle at Town Hall Seattle.
And you've given me a link to that so we can make that available on our website. But that for anyone who is in Seattle, you might want to check this out because that might be a really interesting conversation.
Yeah, and it benefits Clarion West. It benefits Clarion West, which was so helpful to me in actually getting Fiction Science off the ground. So it's like this is coming full circle. So that's very cool. And then
from AI to what other places?
Yeah. I mean, space has been kind of my go-to place for a quarter century. I remember I was at MSNBC back in something like 1998.
And you're like 2000? Nope, go back.
No, 1998. Yeah, and this guy named Peter Diamandis came into the office and he said, "Oh, I've got this idea. Yeah. I want to do a $10 million prize for the first privately funded mission into space." And so that's how the X Prize got started, and that's kind of opened the way for all these players in the commercial space sphere to do their thing. And NASA kind of got the idea. Oh, well, let's leave it more of the responsibility with commercial ventures to get us into space. Like we don't need to own our Ares 5 rocket. Let's let this crazy company called SpaceX do it. And that's how the SpaceX revolution got started, is that NASA decided to take a chance on them. And here now Elon Musk is the richest guy in the world.
And if other space companies had gotten their rockets working faster or, can come up with something cheaper, better, then maybe they might take over SpaceX's contracts. Who knows?
That's an issue. I mean, that's an issue that a lot of people have been talking about. Is SpaceX too dominant in the commercial space area? Is this a problem? Yeah.
Yeah.
So that's something to be covering too. But there are a couple of things other than space that I'm really interested in. One is electric transportation, specifically electric aviation. There's a lot going on here in the Seattle area There's a company called Eviation, which is testing an all-electric airplane. There's another company called Magna X, which is building an electric propulsion system. You see different companies, different air carriers saying, hey, we want to go electric. We realize that the aviation industry is not as sustainable in this era that we're living in, where we're concerned about carbon emissions and climate change. We realize that we need to do something about it. And so maybe this electric aviation revolution is something that they want to be a part of. And so that's another thing that I've been covering.
What are the issues? So electric aviation, you're going to be dealing with battery issues. Do you have
That's right.
to be like, so it's not just like biofuels, which is like your tank of fuel, but this is entirely like similar to electric cars, entirely new systems that have to be developed.
And so that is the issue, is what's the range? And right now the battery technology is not going to support airplanes going. You can't take an airplane from Portland to London just on electric power. Maybe Portland to Seattle, maybe Portland to Cannon Beach.
So a little more puddle jumper kind of flights,
exactly,
which are probably more polluting to begin with.
Right.
When you think about
yeah. So that's there's a company called Harbor Air that's based in the Vancouver, BC area, and they want to go all electric with their fleet, because what they do is they fly seaplanes to different destinations, mostly in British Columbia, and so they're testing retrofitted electric airplanes right now. They're actually older de Havilland Beavers that they've retrofitted with electric propulsion systems. So yeah.
As a bird scientist, I got my PhD in bird brains, and one of the things that is an issue with birds is weight. And so there's this idea that birds that migrate, very often their brains get smaller when they don't need to use them, and then they get bigger when they do need to use them, because they want to optimize for their weight. And so when I think of electric planes and batteries, I think heavy. I think that this is going to be a very heavy thing. Why not do fuel cells? Why not, what is, to me, that this is the weight of the battery? Do you know this? Is the weight of the battery at the same level as the weight of the fuel that they would normally be carrying?
And the hardware, the hardware for an electric, for gas powered propulsion system, that you, to some extent, you're trading the weight of all that metal for a lighter motor system. But you're right that the weight is a big constraint. That's why, the use of carbon composites is sort of an enabling technology to do this. And the idea is that the companies that are in this field are actually trying to hit a moving target. That plane that you're seeing right there, they were able to do that initial test, but in order to do what they want to do, they're really counting on battery technology to advance over the next 5 years. And so, like I say, you're trying to hit a moving target.
Haven't we been waiting for battery technology to advance for decades now?
Battery breakthrough. I used to joke about what's the battery breakthrough headline for this week.
Exactly.
And it's got to be solved, I think, in order to open the way for electric transportation. But and it's a little bit of a chicken and egg problem that you have to build a market for it. And I think that the market is starting to coalesce for that. So.
Yeah, and I would think that the market would generally be there for flight that is, less, if you've got a plane, you've got a plane. I think people are going to trust, are going to accept that that's going to work. But I don't think that market is going to be a problem. But
yeah. And then you mentioned bird brains, and I'm fascinated by the study of the brain, and especially the nature of consciousness. We do have a researcher at the Allen Institute here in Seattle named Christoph Koch, who has done quite a bit of work on that. And in fact, he is focusing on an objective measure of consciousness. I think it's called the phi factor, and trying to see it's related to the interconnectedness of a network, that you would be able to kind of determine what the consciousness of a system might be based on how you measure that interconnectedness. And another fun thing is that he is interested in the application of psychedelic drugs, that magic mushrooms, and that's something that psilocybin is kind of coming more to the fore as a type of therapy. And what does that do to the brain? What are the effects? Can it help with things like PTSD? We're seeing more in that, but we're also seeing the issues. I don't know if you remember that case of the guy who he was a pilot, I think, on a Horizon Air flight, who tried to turn the engines off.
No, that was Alaska Airlines. It was landed here in Portland, where I live.
No, there you go. Yeah.
Yeah, he was on his day off, decided to hop on a flight to somewhere else, and just happened to take magic mushrooms for the first time. Oops! And now I'm suddenly trying to shut down the plane's engines.
So that's an illustration of the problem, the potential problem with psychedelic drugs. So
that could have happened at any time, though. It's just now that people are. I think these stories are highlighted because we are looking at them more as treatments, and so it's
and I think they're becoming a little bit more accessible. That I don't know where he got his magic mushrooms, but I think it's possible in some states, perhaps including Oregon, to be prescribed psychedelic drugs as a therapy. So yeah. So those are fascinating. And actually, the nature of consciousness is going to be the subject of our next Fiction Science podcast in a couple of weeks. We'll be talking with George Musser. He's a science writer who has written a book about the subject called Putting Ourselves Back in the Equation. So that's a look at, and he talks about how a lot of physicists or cosmologists, people who have been interested in the nature of the universe, are getting interested in the nature of consciousness as well. And they're actually pretty well suited to do that kind of work. And so I'm looking forward to talking with George about that. And you can stay tuned for that on Fiction Science Podcast in a couple weeks.
I love that. I can't wait to hear that one, actually, because I've met George and he is just wonderful and his writing is fantastic. So, I'm sure that's going to just be a wonderful conversation. And also the book itself is probably going to be a wonderful read. I'm going to put that on my list, actually.
Okay.
Physicists. All the physicists get to do the fun stuff. I want to do the fun stuff. Oh, wait. Wait, what? I'm talking with you. That's the fun stuff. Well, I do not want to keep you overly long, and it has been an amazing hour of conversation. I have to talk about cats. I do definitely need to tell people about cats because I primed everyone at the top of the hour about cats.
Bring on the cats.
Would you like to leave before I bring on the cats?
No, I'll be with you for the cats.
Okay, you'll stay for my cat stories. I love it.
Yeah.
All right, so let me tell everyone right now, if you are just starting to listen or watch at this moment, this is This Week in Science, and I am joined tonight by Alan Boyle. We're talking all about science and really interesting stories and his podcast, the Fiction Science Podcast, and what is going on in his world. And if you are interested in supporting TWIS, head over to twis.org and click on that Patreon link because we are listener supported. You can choose your level of support. And honestly, your support helps us so much. Thank you for your support. We can't do it without you. You can also hit those Zazzle links. The Zazzle store is full of merchandise and lots of great stuff that will help keep our show going into the future, which we're talking about right now. But right now, on This Week in Science, I am going to tell you about cats. And Alan, are you ready? You're ready for the cats?
I'm ready.
Okay. Do you like cats?
I'm a dog person.
You're
Sorry.
a dog person.
Yeah.
Okay. So some of this you're going to be like, I knew it. And others, you might find just interesting. So first off, there aren't as many cat species as there are other mammalian species, and researchers have been trying to figure out what the barriers to speciation have been through the years with various cats. And there's one study out this last week in Current Biology talking about limited historical admixture between European wild cats and domestic cats. And in this study, they looked at these wild cats and domestic cats that have been cohabitating in Europe for 2,000 years and really only recently have had their reproductive isolation eroded. And so they think that the reason for this is human influences, because it's only really, really recently that these wild cats have started to breed with the house cats. So, other interesting study that follows right on the heels of this one, a genome sequencing project looked into cat evolution. This is from Texas A&M School of Veterinary Medicine and Biomedical Sciences. And the researchers, who are interdisciplinary, they published in Nature Genetics, they determined that cat species, unlike primates and a lot of other mammals, that the cat chromosomes don't have as many what are called segmental duplications, which are, like we were talking about earlier, these really similar copies of genes and these little segments that are copied and copied and copied and copied. Primates, we have lots and lots and lots of places where these segmental duplications take place. Cats do not. And specifically within cats, they have one area on the X chromosome that is where a lot of the genetic rearrangements take place. And so there's a specific repetitive element that they've isolated called DXZ4 that is responsible, at least mostly, for the isolation of the domestic and jungle cats. Why they have isolated and don't interbreed with other species as easily. And this DXZ4 is a repeat. It's a gene that changes the three-dimensional structure of the chromosome itself. It's not just a gene that's like, and now you have brown hair, and now you have white hair, and now, no, it has a role in the three-dimensional structure, and thus the way that the chromosome itself has interactions for translation, transcription, and for copying when it comes time for making copies of genes and interactions. So they don't know the exact mechanisms, but because of the way that they've been looking at these cats and their genomes, they have been able to use a method that allows them to take the first generation of hybrids to be able to figure out exactly how much comes from the parental and the maternal sides of the family, and have been able to really start to piece together the genetics of the cats and why cats don't breed with other cats all that often, and why you have weird meowy, rowery Bengal cats or, a normal house cat. It comes down to these very interesting genetic quirks. And on another genetic quirk note, this is work done by a friend of mine, Jonathan Eisen, and his team of collaborators. One of his, I believe, postdocs has most recently published this. This is a second paper in a series of papers investigating microbiome and volatile compounds in anal gland secretions from domestic cats.
Okay.
Yes. So if you do have one of those Bengal cats and it's a male and it sprays all over the place, or if you have a cat and they're spraying, or every once in a while you might hear about, the cats and their infected anal gland, whatever. Well, these anal glands are very important to cats for marking and for identifying themselves. And in this particular study that was just published in Scientific Reports, they used metabolomics and metagenomics to make really, really pretty pictures of all the microbes that are involved in the makeup of the anal glands of cats, and they found that they are varied. That yes, cats smell differently because they have different microbes, and different microbes are involved with creating different compounds that make different stinks. So those glands that are really important to the way your cat smells, not how it smells and uses olfaction, but how the way it produces an odor, are very bacterially based. And then that goes back again to the genetics of the cat and how there are very specific olfactory genes that have been preserved over periods of time, but that are also very, very defined for particular species and individuals genetically within cat species. This is bacteria to cats to bacteria to cats, and it's a never ending. But anyway, these researchers made a pretty picture.
Yikes. So cat pee is a pretty, it's an important research topic. And I'm reminded of this whole issue about toxoplasma. Have you delved into that?
Very much.
The zombie parasite and how cats kind of spread toxoplasma
Yep. And you are tossing me to the very last story of the night so neatly.
There's one thing I want to say, though. There's one thing I want to say about cat pee is that there have been studies. There's one study I'm looking at here. Fatal attraction phenomenon in humans. Cat odor attractiveness is increased for toxoplasma infected men, while decreased for infected women. So if you have a male partner who suddenly seems to be more attracted to the cat in the house,
or the
get
cat
nervous.
is more attracted to them,
and get nervous.
Maybe this has something to do with who people go, I don't know why cats like me.
Watch out for toxoplasma.
Yeah, well, toxo has been an ongoing topic on This Week in Science for many, many years.
Yes.
We've discussed Justin has an ongoing feud with cats or against cats because of the fact that they become infected with toxoplasma and can pass that infection on to human hosts. Number of countries around the world have massive infection rates because cats are more outdoor and there isn't as much infrastructure for keeping things clean. And so you have these incredible infection rates. United States, we have maybe like 10 to 20% or up to maybe 15% infectivity rates for people who are cat owners or who come across cats, but it can be really, really high, up to 65% in some places in the world. Anyway, last story of the night. Not only can Toxoplasma gondii make you more or less attractive to a cat based on the way you smell, it's also going to possibly make you more frail as you age. So if you have a cat that's been an outdoor cat and you've possibly kept a dirty litter box or dug in dirt outside in your garden that has been used by an infected cat and you've become infected with Toxoplasma gondii, this team at the University of Colorado Boulder, University of Maryland, and University of A Coruña in Spain have determined and published in the Journal of Gerontology, Medical Science, that adults over the age of 65, and in this it was 601 Spanish and Portuguese adults who, when they had a measure known as frailty, which is they get hurt more easily, they're not as much energetic. It's very not. 67% of the subjects were seropositive for a latent T. gondii infection. So not an active infection, but just being infected and having the T. gondii in their bodies. So they don't have an association, and this is where a lot of this stuff breaks down when we talk about T. gondii, is that it's a question of causality. And so researchers can't tell whether or not this is causal necessarily, but there is a correlation between toxo, kitty cats, getting old, being frail. Just a correlation.
I'm glad I'm a dog person.
I'm a cat person, so I'm like, maybe I need to go clean the litter box. I'm gonna go keep that box a little more clean. But yes, I hope everyone out there loves their cats and sleeps well with those little purring predators in their beds this evening.
On that note.
Yeah, exactly. Is that this is how I try to send people off to bed, with a little bit of nightmare juice, just to make you, sprightly. I'm gonna fight the frailty just by adding a little bit of fun. Alan, thank you so much for joining me on the show tonight and for staying a little bit later than the 9 o'clock hour. Where can people find you? I'm going to put links on the website for sure, but let's repeat those websites over again so that we make sure to put it out there.
Well, cosmiclog.com. I put all my stories in some form or another on cosmiclog.com, and that includes stories related to the Fiction Science podcast. You can go to fictionscienceclub.com or fictionscience.club, but just go to Cosmic Log and root around there. You might find a Fiction Science podcast, or you might find a story about toxo-infected cats. Who knows?
Oh, I hope so.
But I do write for geekwire.com and for universetoday.com. And so you'll probably find my stories and a lot more other cool stuff from other writers on those websites. So that does it. I'm on Twitter and Threads and Blue Sky and Mastodon and
the fractionalization of media
Facebook,
has happened.
MeWe. I've got a list of 14 places where I have to tout
MeWe. What's
stories.
That one? Oh, I don't even know.
Yeah. I don't think you want to go there. I'm not that crazy about MeWe, but somebody said, "Oh, you got to put it on there." I don't like Facebook, so put it on MeWe, and so I probably have 20 followers there, but it includes this guy who asked me to do it, so I did. So if you've got someplace you want me to post my stories on social media, let me know and I'll add that to the list of 14.
Oh my gosh. Yeah, these days, oh my goodness. But yes, it's good to have a home. So Cosmic Log is a good start for people.
That's the place
to find you, which is the place. All right, everyone, we have come to the end of the show. Thank you so much for joining us for another amazing episode of This Week in Science. I do want to make sure to thank everyone who is involved in making this show possible. All of you who are in the chat rooms right now, thank you so much to those of you who are in the Discord, the YouTube, the Facebook, the Twitch for being here and being part of a conversation. Thank you, Fada, for your time on show notes and social media, all those social medias. Gord, R and Lore, others, thanks for helping keep the chat rooms safe places. Identity 4, thank you for recording the show. Rachel, thank you for editing the show. And as always, I do need to thank our Patreon sponsors. So it is time to thank them very carefully. Thank you to Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, Rick Loveman, George Corris, Pierre Velazar, John Ratnaswamy, Carl Kornfeld, Chris Wozniak, Vegard Shefstad, Donathan Stiles, a.k.a. Don Stylo, Ali Coffin, Reagan Shubrew, Sarah Forfar, Mundus, PIG, Stephen Albron, Sterile Myshak, Stu Pollock, Andrew Swanson, Fredis 104, Skyluke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hespelosi, Lise Mineke, Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Johnny Gridley, Rummy Day, G. Burton, Lattimore, Flying Out, Christopher Dreyer, RDM, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Rick, Ramus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkonic, Kevin Paranchan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you so much for supporting us on Patreon. We can't do it without you. And if you want to be a Patreon supporter, make sure that you head over to twist.org and click on that Patreon link. Woo! Next week's show, I'll be back. It'll be a surprise who I'm with next week. It's like that mystery wrapped chocolate. What's inside? Every week you don't know what you're going to get. I can tell you. Maybe Natalia Reagan. I'm not sure, but that's who I've been talking with. We'll be back. I will be back for sure next Wednesday, 8 p.m. Pacific time, broadcasting on YouTube, Facebook, and Twitch. And also you can find information at TWIS.org. If you want to listen to us as a podcast, we're on all the podcast places. For information, you can go to our website, TWIS.org, and you can sign up for our newsletter. You can email us directly if you want to say, hey, Blair, how's your baby? Email her, BlairBaz at TWIS.org. TWIS.org. You can email me about show stuff, ask me stupid questions at Kirsten at thisweekinscience.com. You can email Justin at twistminion@gmail.com and say, hey, Justin, where'd you go? And he probably will ignore you. But in the meantime, you just put TWIS in the subject line so that you don't get spam filtered into a kitty cat's microbially filled anal sac. That was not a good way to end this, but we will be back here next week and hope that you will join us once again for more great science news. And if you've learned anything from the show, please remember, it's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.